Today's webinar, Darrin will share his experiences working with large companies and manufacturers to reduce their environmental footprint without substantial investment. So if that's what you're here to hear, you're in the right place. We will get into the meat of the presentation shortly, but first I will review with you how the technology works, who our presenter is, and what you can expect from us today. My name is Kaylin Eklund, and I am a marketing advisor at Eco Canada. As part of this role, I lead our paid and free webinars. Beside me here in Calgary is Danielle. Danielle is the woman behind the keyboard today, so if you do have any questions, you can type your questions in either the chat or the Q&A box on the right-hand side of your screen, and she'd be happy to answer them for you. As well, if you have questions for Darrin throughout today's presentation, you can use those boxes. We will reserve questions until the end of today's presentation, but you can type them throughout and we'll capture them all for the end. We also have Darrin on the call, but all of you, so about 90 people indicated their interest in today's session, and that was both in the public and private sector across Canada. And we do have a range of professionals, both junior, mid, and senior professionals on today's call. So we thank you for joining us. For those of you who don't know, these webinars are a direct outcome of the feedback that we received from our members. EPTs and EPs wanted a platform to share and learn from one another's experience. We recognize many of you who are not members have similar experiences, and so again, we are so glad you joined us and look forward to hearing from you. I mentioned Darrin earlier. Darrin is a senior project manager with Enviro-Stewards, and he's led over 40 conservation audits for food and beverage manufacturers across Canada, and many of those names you'd recognize. So there's like Maple Leaf Foods, there's also that Andrew Peller Wineries, and so he will share those kind of experiences today, but just know that he comes with a variety of experiences, and he also is certified in a number, or has a number of certifications. So you can check out his full bio on our website, and I'm sure Darrin will also expand a bit on a little bit about what he does at Enviro-Stewards. Perfect. So we will be getting started, Darrin. I will just finally remind participants, please use that chat and Q&A box. And Darrin, I'll hand it off to you now.
Okay, great. Thanks, Kaylin. So my name is Darrin Kinsey, and Kaylin gave the brief intro on kind of what I do, and I manage the energy efficiency department here at Enviro-Stewards. And hoping to give a great talk about how to avoid waste and have a conservation-minded focus to sustainability, which is something that's key for a lot of businesses these days. So, getting started, here's a real brief agenda. And so what I hope to start out with is making the case for why conservation should be the first leg that anyone considers when coming up with a sustainability plan or a sustainability focus for their business or company. And go and focus predominantly on manufacturing and kind of why the questions of why there is waste embedded in manufacturing, and then move on to kind of some of the ways that we can tackle that waste and a specific approach which we've developed, which we think is a successful way to tackle that embedded waste, and then share a couple of success stories of kind of how this approach has been used with some companies that you may recognize. So, Enviro-Stewards, we're a environmental engineering company in Elmira, Ontario. We're about an hour outside of Toronto, and our corporate mission is to help companies increase their profits, sustain the environment, and compellingly benefit society. We're certified B Corporation, which is a different type of corporation, and that is one that also has a mission of accomplishing a social good. Enviro-Stewards, we're also heavily involved in the Safe Water Project, and that's where we teach communities without access to safe water how to build slow sand filters in order to generate clean water, clean drinking water. All of their biosand filters, which are all made with local materials, and instead of a charity model, these projects are run as local businesses, and that's something inherent in sustainability itself. These businesses, all of the money stays within the community. And right now we have 4 projects in South Sudan and 2 in Nairobi. So Caitlin mentioned briefly of some of the companies that we've used the approach that I'm going to be talking to you about, kind of some brand names that everyone would be familiar with in Canada, and everywhere from 32 factories in Maple Leaf and 6 for Kraft Foods, and multiple projects at Campbell's. And also, those are all food industry, but also work successfully with heavy manufacturing, Bombardier and Toyota. So, manufacturing there's a big push for sustainability and a lot of opportunity. So, companies have many reasons for wanting to approach sustainability in their operations and in all that they do. And we kind of try to take the approach that no matter kind of what their purpose or what the driver is that's pushing them towards sustainability, that you can always end up at a common endpoint. And so one of the most common drivers we encounter is just the financial drivers of the reasons for sustainability or wanting to pursue it. So everyone's aware, electricity prices have been going up for a long time, and so manufacturers can no longer, spend pennies for their kilowatt hours. It's becoming a major cost on their bottom line. Different levels of government are introducing costs on carbon, and there's big drains on a company's bottom line. And one of the other things is that municipalities and, for instance, some of the utilities have essentially what's called capacity buyback programs, whereby they'll incentivize companies to reduce their resources. So if you have a financial driver for pursuing sustainability, then one of the best ways is right now we have opportunities where you can have someone else invest in the capital to pursue sustainability. Other drivers for companies to pursue sustainability is just overall corporate goals. It's great PR, it's great marketing, and a lot of companies are realizing that it's actually something that's quite important to their clients, and so they want to be out there with bold and audacious sustainability goals. Example, Maple Leaf Foods is committed to reducing their environmental footprint by 50% by the year 2025. And a lot of other companies are following suit with that. Then lastly, there's also policy is what pushes a lot of companies towards looking into the sustainability of their operations. Municipalities have had sewer use bylaw regulations for decades. And so even, municipalities are pushing you, if you're out of compliance, then, you have to change the waste inherent in your operations. And, typically the companies that are leading the pack within, towards sustainability and reducing the resources are the ones that, do it for nobility reasons and that it's the right thing to do. But whatever kind of the overall driver for a company to start pursuing sustainability, we find that often the question is kind of where do you begin? Like, what does the starting line look like, or what does even the finish line look like? And so there tends to be 3 areas where there's a common focus of companies they've decided to dip their toe in the water, go towards sustainability, and so there's 3 typical approaches. And so a very common approach is renewable energy. And so, a lot of people, companies boast that, there's the solar panels on their roof. They are replacing a portion of their consumption with, green generated energy. But what we find is that if you're pursuing renewables first, it's essentially you're leaving, you're not addressing any waste that's inherent in your processes. And these types of renewable projects can be very expensive and very resource intensive themselves. So for instance, if you wanted to generate 22 million kilowatt hours a year of electricity in Canada, it's going to cost you about $42 million in capital, and it's going to use 57 acres of land. So these are, hugely capital intensive, resource intensive, and you will generate a fair bit of revenue, $2.2 million if you're getting, 10 cents a kilowatt hour. But from a strictly, if finances are your driver that's pushing you towards sustainability, a 19-year return on investment is not going to be very attractive to many CFOs out there. And so there's many types of renewables. Another example would be wind, which is gaining popularity in Ontario. In a similar scenario, to generate that same amount of electricity, you're going to need 18 acres of land, $24 million, and if you're lucky, after about 11 years, you'll be getting your money back. But it also has, there's a lot of controversy around wind power, from bird mortality to bothering people with hums who live too close to it. So, renewable energy isn't always the magic bullet that it is touted to be. So what we find is that if renewables aren't the first thing that people should be looking at if they're going to be trying to more sustainably run their business, then often technology is thought to be the solution. And so here's a couple of examples with technology. And so virtually every business or commercial institution needs to heat water. It's an extremely common process. And if you're going to heat water with natural gas, typically it's about an 80% efficient process. And so if you're looking at technology strictly as this is what is going to make our business more sustainable, then you might look at this technology that's on the left. It's a direct contact water heater, and it's 98% efficient. You can't get a more efficient natural gas burning technology. And it's a great technology. It will accomplish a task that you used to use 5 units of natural gas for with 4 units of natural gas instead. So it's a great piece of technology. But if you only focus on technology, you might ignore the fact that of what you see on the right. And so on the right there is a cooling tower. And the sole purpose of a cooling tower is to pay to get rid of heat that you're generating in your building. And so if you ignore the fact that you're paying to get rid of heat, that heat could be used to partially heat your water. And so if you're using heat that you were previously getting rid of, then you can raise the efficiency of a system over 100%. So by looking to see, well, where else am I getting rid of heat and what can I do with it, you might come up with a different solution that technology wouldn't necessarily be the core solution for. On the left there is a variable speed air compressor, and compressed air is the lifeblood of manufacturing. It is used virtually everywhere. I'd be surprised if even 1% of factories didn't have an air compressor there. And the common approach is we need a variable speed air compressor, which basically ensures that the old style of air compressors, they consume a fair bit of electricity when they're not making air. So this variable speed air compressor, it is a better technology. It will generate your compressed air more efficiently. And that is the focus if you're just looking at technology. But people rarely look at, let's look at the whole system and how that compressed air is being used in the first place. So at the top, you see compressed air being used to blow water off of parts. compressed air is the most expensive utility there is, and so that's an extremely expensive way and wasteful way to remove water from parts. At the bottom there, that is compressed air being used to essentially create bubbles in an electroplating process. And once again, it is an extremely expensive way to make bubbles. You can purchase an electric blower that would use 1/8 of the energy in the first place. So technology isn't the solution. Even on the left there is just a hand applicator for compressed air that a lot of people use to blow debris off of equipment and areas. And so that's an extremely expensive substitute for a broom. And so looking at how the resources being generated is only half the story. If you look at how the resource is being used, and if you need to use it in the first place, you come up with a lot of different answers. And so technology, once again, isn't always the solution. And finally, on the left there, this is an anaerobic wastewater treatment plant. And if you are treating your wastewater, this is probably the most high-tech way you can go about doing it. It generates its own natural gas or methane that can then be used in a boiler. And, that's some would say a very, sustainable solution. But people rarely look at, well, why are we treating wastewater in the first place? And often it's food manufacturers, and what is in the wastewater is what was once an ingredient. And so instead of using technology to destroy these ingredients, if you go into the factory and ask, why is it getting in the water in the first place, and what can be done to avoid that, then ideally you're ending up with these products, as a saleable in a package, as opposed to having to be paid to destroy it in a wastewater treatment system. So I hope I've made the case that renewables and technology, while there's a place for them for sure, they shouldn't be the primary focus, and it often detracts from what is the real problem, which is waste. And so what I'd like to suggest is that a conservation-first mentality is what is most appropriate in order for businesses to pursue sustainable manufacturing practices. And so there's that old adage, reduce, reuse, recycle, and I'm sure everyone's heard it 1,000 times, but there's actually meaning to the order of those words. And so reduce is first because that's the most effective thing to do. If you eliminate the waste or don't use something in the first place, that's what you do first. And then you look at the reuse and recycle or the technology and the renewables. And so if you focus on those renewables and technology first, you're just essentially, you're wasting your resources more efficiently. And what we want to do is not use them in the first place. And also hope to show in those previous examples is, between, the solar panels and the variable speed air compressors and all of this technology, it's very expensive. And conservation, on the other hand, can be one of the most lucrative avenues that any business pursues. It's so much less expensive not to use something as opposed to using it more efficiently. So when I say conservation, a lot of people tend to think that conservation means something similar to what we see in this chart here. And I know it's a little busy, and I'm sorry for that. But in Ontario, every hospital has to come up with a 5-year conservation and demand management plan. And so this is an unnamed hospital. They have to publish this, so it's all publicly available. But this is what a lot of people think of when they think of conservation. So if you look at this hospital's plans, there's a lighting upgrade, and most factories, they have to address their lighting. There's improvements that can be made. And so I don't want to comment on that line item, but if you look at the other line items, you very quickly see that, one person's view of conservation isn't necessarily one that means reducing waste. There's talking about, the fourth item is replacing an air handling unit, and further down there's replacing a chiller. And if you think about inherent waste, I mean, taking a perfectly serviceable piece of equipment and replacing it and buying a $200,000 new one with the hopes of getting your money back in 15 years doesn't necessarily really feel like conservation. Same with replacing an entire roof. It really doesn't touch upon other factors of, there's a huge amount of waste inherent there. So looking at this hospital's conservation plan, one thing really struck me, and that was none of their opportunities of where they see conservation available, none of these opportunities really address what's happening inside the four walls of the hospital. Nowhere does it address the waste that might be inherent in the practices or the use of equipment within the hospital. And so a far more effective approach is looking for waste instead of, potential minor gains you might get by replacing a roof and getting a 20-year payback or replacing a main giant piece of equipment. So, so when I speak of waste, these pictures might give an idea of what a lot of people would think of as waste in a factory or in a manufacturing process. And you can see, there's huge leaks. It's almost, I'd call it almost kind of egregious waste. And this is something that, yes, while this is waste inherent in manufacturing, this is the type of things that, would typically be fixed quickly. And so the main part of my presentation, what I'd like to talk about today is that, of course, if you see leaking steam, fix it right away, but there's hidden waste, and hidden waste is actually where the greatest opportunities are. And hidden waste doesn't look like these pictures here. Hidden waste looks much different, and you almost need to have a different slant to how you look at things in order to find it. So in order to kind of bring home where the hidden waste is, in a process, in a company, I want to discuss a little bit about why there's waste in manufacturing. And so often why there's waste comes with, the first person responsible is the engineer who designed the factory, who designed the system. And so if you think about it, if you have a process that is integral to your production, what happens if the engineer underdesigns this integral process? The biggest problem is that the process isn't functioning how it was designed. The engineer essentially gets kicked out of the door. So what ends up happening is potential over-design. And so what you see there on the left is hot dogs, and the hot dogs are essentially, when they're cooked in a casing. And so that casing has to be removed, and that casing is typically removed by a vacuum system. And so a vacuum system is very similar to what like a central vac in your house or a shop vac. Now, this is industrial size, and so the vacuum system in this particular example was working perfectly. It was collecting all of the casings from the hot dogs after they were cooked. The problem is that it was over-engineered. The actual amount of power to run this vacuum system was equivalent to the amount of power that's used to move two of the roofs on the Rogers Centre in Toronto. It was a total of 750 horsepower just to collect some cellulose casings. And so it was over-designed and a huge amount of waste that was inherent. Another reason why there's waste in manufacturing is that people stop looking at their surroundings. Your surroundings become wallpaper. And this is an example of a screen in a food manufacturing facility. that is right where all the employees come into the production floor and leave the production floor at the start of their shift, for breaks, for at the end of the day. And so there's 200 people that pass this sign at least 4 times a day. And so that's 800 sets of eyes that have the opportunity to look at this sign every single day. And the problem is that while you might pass by it and see that they're wishing you a great day today, the problem is that no one actually pays attention or looks closely at the information there. And so if you look at what's circled, the information is actually telling you that you have 9.8 Celsius water going to your cooling tower, and that after the water is cooled by your cooling tower, I'm using hand quotations for cooled there, it actually ends up at 10 Celsius, or it's warmer. So in another respect, the factory is using their cooling tower to bring heat from the city of Edmonton into their chiller system, where they're then using electricity to remove that heat, and it's a continuous loop. And so, this information was available to, those 200 people who passed by every day, but they never knew that the most efficient thing to do would be that when they ran this particular product would be just to turn off the entire system. That would be the most sustainable thing to do. And so, that's a particular reason for the waste, and you can eliminate pumps and fans of this entire system. And so if you're looking at just more efficient pumps and fans, you sometimes miss the greater point. Other reasons for waste, of course, is maintenance. So on the left there is a completely rusted out valve. It's a temperature regulating valve. And when that valve functions, it does the job of limiting water flow to as low as practical, depending on the discharge temperature it's trying to maintain. Now this one has been very rusted out, and as a result is continuously leaking out 20 liters a minute. And 20 liters a minute may sound like a lot of water to some people. It might not sound like a whole lot to other people, but 20 liters a minute, every minute, all year long, 24 hours a day, adds up greatly. In this case, it's over 10,000 cubic meters of water a year. It's almost $35,000 of water a year. And I bring up maintenance. It's not because the maintenance staff at this factory were lazy, or even in this particular case, it's not the fact that they were unaware of the problem. Maintenance staff have budgets, and they weren't aware of how much water they were losing. They weren't aware of the cost, and so they deferred spending the $500 on a replacement valve until the money was available in the budget. And so that can be a particular problem with maintenance. The other on the right is it's a similar problem and a similar 20 liters a minute of lost water. But in this issue, the valves failed open, and it led to pipes that were hard piped into the facility's drains. And so simply no one knew that water was flowing through when it wasn't supposed to. It wasn't something that anyone could physically see. Another reason for waste is, in manufacturing, there's this mentality that production and sales are the most important metric of all. If you talk to any CEO, I bet you they can tell you what their sales increases have been year over year, what their production numbers are year over year. But when you have that singular focus on production, often you have like Band-Aid solutions that can lead to waste of resources because you have to keep that production line running, or you have to get that next sale. But this hypothetical widget company, hypothetically, if the product they sold, their widgets, had a 5% profit margin, and that company spends $1 million on utilities, there's two ways of looking at how that company can make $100,000 in profit a year. So option one, which is the most common one, is sell and produce an extra $2 million in product every year. So that's an extra $2 million of sales you would need every year to get your $100,000 profit. And so, you cut a lot of corners and you waste a lot of resources always chasing, those increased sales. But another way to make that exact same profit is to cut your utility costs by 10%. And I'd argue in most cases, you'd need less resources, less expenditure to cut those utilities by 10% than to raise those sales by $2 million a year. Another reason why there's waste inherent in the system is just the vendors and people who sell resource-consuming equipment. I mean, one common question is, who does compressed air audits? And the answer to that is it's vendors of air compressors. And so what's in their best interest to say that you need? And they're going to say it's a variable speed, top-of-the-line compressor, kind of like the one that mentioned earlier in the presentation. And the common question also is, what size do you need? And, you need to cover demand and, let's add a safety factor. You need to increase those sales. And so you want this air compressor to control that. And what you end up with is that you can just have equipment that's oversized. So the diagram there is a amperage draw of a variable speed, top-of-the-line air compressor at a winery. And you cannot get a better air compressor. But the problem, and when you see a whole bunch of red there, that's something turning on and off continually. It's just too big, and it uses too much energy, and the winery ended up buying an air compressor that was 1/3 the size. It draws half the amperage, and they use a significantly less amount of electricity. An analogy to this is it's sort of the winery essentially had a Ferrari that they would drive 100 meters and slam on the brakes, drive another 100 meters and slam on the brakes, and they replaced that Ferrari with a reliable Honda Civic that just drives the same speed all the time. And those two scenarios, you can see what is a more wasteful use of energy. And so a lot of people think that when they have a brand new factory, and you're often told that you have a turnkey factory and that everything's working perfect, they often think that you are running optimally. And so on the left there is a picture of a hot water tank. And so here's a factory which, as the factory was coming online, they had the problem that it was imperative that their boiler be firing at full first thing in the morning. And so when they were starting up the factory, the solution to get that boiler running first thing in the morning was that they would dump the contents of their hot water tank. And the purpose was that the hot water tank, or the boiler, would then have to make up all of that hot water. So to get started with the factory, they were dumping 30 cubic meters of perfectly good hot water a day, and it had a purpose. But that was the purpose right when the factory started. And 3 years later, when we went into the factory, we found that this practice was still occurring. The boiler was no longer even heating the hot water that was in the tank. So essentially, the program that runs the boiler room was dumping 30 cubic meters of water and having no impact on the boiler, or not the desired impact. And so, it's the way a factory is first commissioned. Very often, some of the most wasteful scenarios is that it's has been commissioned incorrectly, or that once it's up and running, things change. Another quick example is looking only at one utility. So here's a solvent manufacturer, and if a traditional energy-focused approach is to say, if you have any exhausts, that's where your energy is going. And so if you only focus on, for instance, a single system like that exhaust, you're typically missing the larger picture. So instead of seeing what more efficient type exhaust you can have or how to recover the heat from an exhaust, we asked ourselves, well, why is the exhaust there in the first place? And the reason was that in this room, it wasn't safe to breathe. And so instead of, exhausting those fumes outside of the wall, we asked, where's those fumes coming from? And they're coming from the still bottom tanks at the bottom of the diagram. And so by putting a lid on those tanks and condensing the fumes that came from them, the company actually had a saleable solvent product instead of sending their solvents out of the wall. And so it was then safe to breathe in the room. There was no need for the exhaust. And so it's by asking the why in the first place, you come up with different answers. A final example is that simply there's waste because the people in the plant can't know everything that's happening. And so this blue line is essentially the temperature coming out of a fume hood in a hotel. And I talked to the last person who leaves that area every day, and they said, yes, every day I turn off this fume hood. And I also talked to the person who starts up that operation every day, and he said, every day when I show up, it is off. And so the facility was convinced that, during the night, that fume hood is off. But if you look at the blue line there, you see while the line goes down, once everything's turned off, very shortly thereafter, it comes back on, and it stays on for most of the night. And so what was actually happening is that when the cleaning staff came on, they just turned everything on in the area, and including the fume hood. And so there's so much that goes on that people aren't aware of on the plant because you can't possibly know everything. And so there's a myriad of reasons why there's waste, everything from inertia and training and culture, but those are often, the reasons for waste, they're often engineering issues, and there's often engineering solutions, but actually change management solutions are just as important as the engineering solutions. And so what we feel is what's most successful is to pursue what we call is a systemic approach to conservation or waste reduction. And so the systemic approach portion is looking at everything, looking at the electricity and the natural gas and the water and the wastewater all at once, because they're all interrelated. Very rarely is there just a single waste of water. It also, if it's hot water, then it influences natural gas or maybe also electricity because that water's pumped. Everything's connected, so looking at it all together gives you solutions on how to be more, have more sustainable practices and eliminate that inherent waste. And so we talked about change management, and the approach to addressing waste in a facility is engagement with the staff. If you bring in a consultant, they might give you 20, 30 fantastic ideas on how you can eliminate your waste, but it's the people on the floor, the people who are still at the factory once the consultant leaves, who are going to be the ones implementing it. And so getting their buy-in that, you want to pursue sustainability, getting their buy-in on day one is critical so that they're part of the process and, not told that the change is coming or even resentful of the change. And then the next critical portion of kind of any waste reduction project is collecting reliable data. And it can be a mammoth task. Data collection, it's feet on the ground, it's no stone unturned, it's looking to see where pipes lead, it's looking to see when motors are drawing electricity, when they're not. It is fully knowing where all of your resources are going within the entire process and within the entire facility. For instance, at the bottom there is it's water flow from the water main of a food manufacturing process. And so monitoring the flow rate of this water main, you see that the flow never goes below 50 liters a minute. That right there should be screaming to someone of, how come when the factory's empty, we're still using 50 liters a minute? On the left there is it's monitoring the heating and the cooling of a room in a gold LEED certified building. And when you see thick black, it means something's turning on and off. And so both the air conditioning and the heating system are continually turning on and off in this LEED gold certified building. And so this room it's heating and cooling itself continually. And so, it's the only way you can find out these things is by actually logging and monitoring and measuring it. And so once you've logged and know where all your resources are going, then it's good to, graph it out in a Pareto chart or to take stock of where these resources are going and does it make sense. So for instance, this is a food manufacturing facility in Alberta, and the plant staff before the project were convinced that sanitation used most of their water. And after all of the monitoring and the logging, we found that actually sanitation only uses 7% of the water. And so when it can be impactful to see and surprising where your actual resources are ending up. And so, if it's not where you thought, then it starts to elicit more questions and new questions of, well, if that's not where it's going, why are we using so much in other spaces? And so basically it turns into a root cause analysis or a cause and effect. And so a facility to reduce its waste needs to continually ask itself why, and why are we using this resource here, and what good is it serving us? Is it for cooling? And if it's for cooling, then maybe could that cooling be accomplished for some other way and a less resource-intensive way? And so, by asking the root cause of why we're using resources in every single process, you start to develop opportunities on how you can reduce the use of that resource. And so what we always find is once coming up with opportunities on how to reduce resources is bringing the same team back together again and to vet ideas and concepts of the opportunities. Once again, these are the people who are going to have to live with the change, and they're going to be the people implementing the change. And so in order for successful reduction and elimination of waste, these people need buy-in, and for them to agree that it's feasible, yes, the concepts are feasible, and they think that they will work. And then it's the people on the floor might agree to a waste reduction strategy, but the company as a whole needs to be convinced, and financial reasons are typically what is the most impactful or convincing. And so, once the people implementing change and living with it agree in principle to an idea, then that's when it's a good idea to develop the cost analysis and the request for funds. If they don't think that the idea is going to fly in the first place, there's no sense in using resources of trying to figure out how much something's going to cost. And lastly, monitoring and tracking of implemented initiatives is critical. A lot of people, they have the good idea, they spend the money on it, but they never actually check to see, is it doing what it's intended? And unless you can confirm that it's doing what's intended, it could be implemented incorrectly, or it's just not realizing the same amount of savings as you want. So a couple of examples of opportunities that might use a systemic approach is this is a picture of actually our office. We had an expansion, and our goal was to reduce heating and cooling costs in the office. And a traditional approach on how you would do that would be, let's buy a high-efficiency furnace, or let's look at heat recovery, or let's look at the insulation of the building. And those are all viable things to look at, but it shouldn't be the first thing you look at. The first thing you look at is, why are we using heat and cooling in the first place? And bringing in fresh air into the building, into any building, is one of the most resource-intensive processes. Heating up air in the winter that was -30 to a comfortable temperature uses a lot of natural gas. So with that in mind, we said that's what's using the natural gas. That's what uses a lot of the electricity in the summer. So we decided to install a living wall that fed our air makeup and our air handling unit. And so the reason why fresh air is needed in a building is often because of CO2 from people breathing. And so the living wall reduced the amount of CO2 in the air, and so since the CO2 has been reduced, there's no need to bring in fresh air. That reduces the amount of natural gas and electricity needed, and so the living wall requires water. So we tapped into one of the rain leader downspouts that actually ran through the office and collect rainwater in order to service the living wall. So in this example, with a goal of reducing heating and cooling, we in the last year have not brought any fresh air into the into the building. It's all been conditioned by the living wall, and we haven't used any water or tap water to service the wall. Another brief example here. It's a very, it's a complex diagram, but the takeaway is that this is a dehumidifier with a flame that is the small circle, and that flame fires on that wheel at all times. And so this is dehumidification. Is the purpose of the piece of equipment here, and it's rarely needed in the winter. So when we're at this facility in the winter, we asked, well, why is this on, and why is this flame still burning on the wheel? And the reason is that they were afraid to turn it off, because in the winter, they were afraid that it might freeze up their heat exchanger, which is the larger circle. So they were afraid that at a cold startup, it's going to essentially make the equipment unviable. And so instead of just running it all winter, when your actual concern is the startup process, we recommended that they just retrofit the unit itself, so that 5 minutes before it starts up, you have an electric coil that warms things up and eliminates that concern on the heat exchanger. So, asking the why and finding a different way comes up with different solutions. Another example for a great systemic approach is repurposing utilities. So here's 3 different pieces of equipment that are serving 3 different processes, and they all need water to do a different task, whether it be provide a seal in a vacuum pump or to clean that rotary screen in the middle, or to provide cooling in that boiler blowdown tank. So each of those individual processes could be improved or maximized efficiency in one way or another. What we found using a systemic approach is that let's just use the same water stream to accomplish all 3 tasks. And so in using that same water stream, you're using the heat from some tasks to provide the required heat that you were using natural gas for before. And so this single stream of water is now providing 3 pieces of equipment with its water needs to produce 3 different purposes. And it's $110,000 of water less a year once you look at a system holistically. Lastly, here's another example of a facility where 22 liters a minute, there's piping hot water, almost boiling, running down the drain. 22 liters a minute all year long. And so when we asked the operator the purpose of why is there 22 liters a minute of hot water going down the drain, he said it's because there's some lard going down the drain. The lard there is in the picture of it in the left corner. And so the water is serving its purpose, but then we asked, well, why is there lard getting in the drain? And so the reason is the top arrow is a centrifuge that every 4 minutes it spits out some solids and a small amount of lard that goes into the drains. And they don't want the lard to solidify in the pipes, so they send down hot water. So using a holistic approach of looking at the system as a whole, whenever that centrifuge sends some lard and solids out, instead we said, well, why don't we recapture it and keep it in a heated tank and reprocess it back at the beginning of the process. And then you no longer need the hot water, and you actually are recovering a lot more saleable product. So once again, if you keep asking why further enough down the process, you come up with different answers. So a brief example of this all in action was Tim Hortons. They own a icing factory, Fruition Fruits and Fills. And so the factory, they had a problem is that the city of Oakville was saying that there was too much loading of organics into their sewer, and that they would have to reduce the organics in the sewer or treat their wastewater. And so what we could have done would be follow the traditional approach of how this work is often done and build a huge wastewater treatment plant. But it would have used most of their land. It would have cost over $1 million, and it wouldn't be the most sustainable thing to do or impact waste the most. So instead, we found ways for the facility to reduce the wastewater, their overall water use, their loading to the sewer, which was ingredients. The ingredients ended up as icing and donut filling instead of being in the wastewater. And we looked at the electricity and natural gas and everything all at once. And so on the right, you can see kind of the blue is their footprint of those items beforehand and what the factory was doing afterwards. And so often people feel like this is capital intensive and costly work. But according to their own internal numbers is that, they spent $187,000 and that their savings on gas and electricity and sewer surcharges was almost $500,000. So it ended up being, less than half a year to get their money back. And the plant manager, took that money. It's a 40-person factory. He gave every employee a $4,000 bonus, which helped with the, because their engagement was critical for this being implemented. And Tim Hortons received the other, $8,000 per employee. So it can be extremely lucrative work to address waste first. The Tim Hortons plant manager then went with this president of Enviro-Stewards to South Sudan. They sponsored some water treatment biofilters, and the work of their conservation as well as the development work that ensued became part of Tim Hortons' sustainability report. And they also won a Clean 50 award for one of the top 5 sustainable projects in Canada in 2014 based on this project. And so one more quick example is Vincor. They're a winery. This particular winery is in British Columbia. And so, once again, they had a driver of, their wastewater had a lot of organics in it. And, the source of the organics, that's wine. And so instead of, addressing the problem first through a wastewater treatment plant, found ways within the factory through engineering and behavioral modifications to decrease the wine losses by 2/3 and to decrease the overall water by 50%. So while the facility still needed to buy a treatment plant, the overall treatment plant that they had to build, the capital was $1.5 million less because they had just had to treat far less water and organics within their wastewater. So, a conservation first and a waste reduction approach, saved $1.5 million on the capital. And so I think overall, with a lot of the examples I've given, perhaps some people might have the overall feeling of, perhaps some of this is somewhat obvious, and why isn't this, a greater focus of plants? And one of the larger reasons is, by having a wastewater treatment plant that was $1.5 million less, well, the design fee for the engineering firm that designed this wastewater treatment plant, design work is typically 10% of what you build. So by reducing the amount of wine losses and the amount of water being used, we worked ourselves out of $150,000 in work. And so it isn't traditionally a large focus of companies, because engineering firms, because it might be lucrative for the customer, but it isn't always lucrative for the engineer. So that's a couple of examples of kind of how a systemic waste reduction approach can be successful in manufacturing. And so just a couple of brief takeaways is, even in a brand new facility, or even if you think that you run a tight ship, or you don't see anything obvious, there's no leaking pipes, there likely really is still low-hanging fruit in that facility. And that conservation, it really is one of the most lucrative investments a company can make. There's very few investments that often have a 1-year payback or less, but that's often the type of financials that you see in a waste reduction study that's been done properly. And that looking at the system as a whole is critical, and that if you're just looking at a singular system, a singular process, or a singular utility, you're not going to be able to realize the full potential and identify all of the waste that would be in your facility. So that is it for my presentation. My contact information is up there. You're more than welcome to give me a call if you wish, or drop me an email. I'd be more than happy to talk further on anything that was mentioned. Yeah, I guess over to you, Kaylin.
Thanks so much, Darrin. I know Danielle and myself were both scribbling notes as to what you were saying. I'm very interested in what you had to say, and I'm sure a lot of the participants are feeling the same way. If you do have questions that you would like answered right now, we do have a few minutes, and you can type those questions in the chat box, and we can relay them over to Darrin. What I would say, one of the points you mentioned, Darrin, about really asking the why, and eventually you'll get that solution, that really stuck out to me. And I even know in our calls we were talking about, it is obvious. A lot of these things are obvious, but it's really kind of addressing that obvious. And as you mentioned, it's not always going to work out in favor of the company who is kind of supporting it. It's not as lucrative for your company at Enviro-Stewards, but ultimately you are making a difference, and that's kind of the sacrifice that your company has decided to make to advance sustainability in a lot of cases. So we appreciate that. Again, participants, please ask your questions in the chat box. Take advantage of that. I will mention, if you are on your way out, that there is a survey. You can also indicate on that survey if you want to get more information, and we can pass that on to Darrin as well. The survey allows us to improve our webinars, and it also gives us a chance to give kudos to Darrin's work. So if there's something you really enjoyed about today's presentation, you can say that in the survey, and we'll make sure that Darrin receives that feedback. Are there any questions? No, okay, so it doesn't look like any questions are coming in. You must have covered everything for them today, Darrin. So thank you again for sharing your expertise and for sharing your contact information as well. I'm sure there will be people following up with you to discuss it further. We invite everyone who joined us on the call today to join us again virtually and learn topics that are relevant to you. So there are a wide range of webinars going on this fall, paid and free, and we encourage you to take advantage of them. There's also other events, so keep your eye open. Darrin, final thank you. I'll connect with you after today's call, but I just want to say thanks again for sharing your expertise, and please pass on a thank you to Enviro-Stewards for allowing you to join us today and present.
Great. Thank you very much.
Wonderful. Okay, take care.
All right. Bye.
So if you click on the recording.